We will discuss our paper entitled Application of Dynamic Bayesian Networks in the Context of Philippine Rice Food Security. As the nationwide demand for rice increases while supply decreases, the hunger incidence in the Philippines increased through the years. Hunger incidence rose from 7% to 13.3%. The high retail price of rice also reduces the purchasing power of the income of the poor. Philippine retail price increased by 35%, and Philippines was also the biggest importer of rice in the world last 2008. This prevents the country from being 100% rice self-sufficient. This study uses dynamic Bayesian network to determine the decision support for food security and connection to possible fluctuation in rice industry. The continuous variables have been discretized since the purpose of this study is to determine the level of rice production and retail price of rice in the Philippines based on situations. The discretization process is a process using a benchmark of average annual growth of the variable. The interval was obtained. In this study, a benchmark was used by attaining the average annual growth of all the variables excluding typhoons from various literatures.
The average annual growth of Philippine retail price for rice is 4%. It was categorized into very high, high, and moderate, which corresponds to 100%, 50%, and 10% increase in average annual growth of retail price, while low is categorized as a decrease of 10% in average annual growth of retail price. All of the variables adhere to a similar protocol. We use Netica as the chosen software for this paper. The Bayesian network structure is composed of 12 nodes, and directed edges between the nodes indicate the relationship among the nodes. Some nodes have displayed definite hierarchical relationships that affect others and are influenced by others. A time delay link is a directed edge that indicates that the child node value depends on the parent's node's value at the earlier time. Time delay links were added to the Bayesian network to make a dynamic Bayesian network, which were based from time series models. After the Bayesian network structure was formed, the parameter learning was carried out. Parameter learning is the automatic learning of particular relationship nodes have with parents' nodes using case data. Once it had been decided which nodes are the parents of each node. In Netica, different links may have distinct time delays. Thus, time slices may have a distinct structure from each other when the network is extended. In this paper, the delay amount for all links is 1. Therefore, Netica will replicate nodes that has a time delay link in the expanded net. This means that when the dynamic Bayesian network is expanded, some nodes in the Bayesian networks become multiple nodes in the expanded net, showing the variable's value at different points in time.
In a Bayesian network, states and events are denoted by variables assigned to a certain value. When working with Bayesian networks, a scenario is defined as a value assignment to a collection of nodes. Various scenarios that greatly affect the food security in the Philippines have been examined. For all the expected trend that were produced, it was calculated as shown here in the formula at each time period. The basis of this computation is the categories of variables in a discretization process. It was categorized into high and moderate, which corresponds to 50% and 10% increase in the average annual growth of retail price in rice production, while low is categorized as a decrease of 10% in average annual growth of retail price in rice production. The influence of Philippine rice production when typhoon is set to high is a decrease from 44.4% to 43.5%. In order to assess the medium-term effects of the typhoon in Philippine rice production, the 2-time slice DBN was run for 1, 2, and 5 time steps to approximate 1, 2, and 5 years respectively. After a year, the model shows 35% probability of having a high rice production under the influence of the typhoon, which is a decrease from the previous year of 43.5% probability. The model with the influence of typhoon in the following years also remained at a 35% probability of having a high rice production. The same procedure was applied to the rest of the variables. All the results are shown in this table.
Our study shows that typhoon and the integration of typhoon and area harvested caused the downfall in the Philippine rice production. Furthermore, world rice price and the integration of Philippine rice consumption and the Philippine total supply bring about an increase in the retail price of rice, while the high amount of rice imports in the Philippines impact the rice industry by causing a decrease in the Philippine rice retail price. Recommendation for future studies can include other factors in dynamic Bayesian network structure, such as weather and government programs that may impact the Philippine rice production and the Philippine rice retail price. Thank you for listening.